Hi, we are from Group 3B and the lab we choose is Lab 10, Analyzing Convection Process and Sublimation Rate.
The objective is to investigate the influence of cross-flow velocity on sublimation rate and compare the physical changes of naphthalene before and after the exposure. The apparatus used are naphthalene sphere, aerodynamic unit, pitot cube, digital weighing scale, and vernier caliper. Make sure to always wear closed-toe shoes and always wear a lab coat during lab session.
Next, we step into the procedures of this lab. First, the diameter of the naphthalene sphere is measured using the calipers. The naphthalene sphere was then weighed using the digital weighing balance and the initial mass was recorded. And this is the equipment we need to use later. Before that, one end of the mounting rod is heated to facilitate the sphere attachment. The naphthalene was then mounted on the rod. The rod with the naphthalene sphere was then mounted securely onto the deck section of the cross-flow heat exchanger. And the opening of it was set to 50% airflow. Then the start button was pressed and left to sublimate for 20 minutes. Then, the velocity values were recorded using the anemometer at the end of the 20 minutes. The final temperature of the heat exchanger was then recorded. Upon completion, the airflow was turned off and the naphthalene sphere was then carefully removed. The final diameter of the naphthalene sphere was then measured using the caliper and recorded. The final mass of the naphthalene sphere was measured as well using the digital weighing balance. Step 1 until 11 was repeated and the opening for now was set to 100%. And that's all for the procedure of this lab.
Lab coats, safety goggles and gloves must be worn at all times during the experiment to ensure personal safety. Then, any waste materials generated during the experiment must be disposed according to the established laboratory protocols to ensure environmental and personal safety. Lastly, keep hands, clothing, and loose items away from the aerodynamic unit and airflow path to prevent injury or disruption of airflow patterns that could affect results.
For result, we can see here we have two types of table. The first one is table 5.1.1, showing that the data before the naphthalene exposed to the cross-flow condition. And then for before experiment, we set constant value for both experiment, which is 20 minutes for the time. And then we set sample 1 as 50% cross-flow, sample 2 100% cross-flow. And then after 20 minutes, we can see that sample 1 and sample 2 have decrease in data, which is the diameter of the sample 1 and sample 2 decrease, mass sample 1 and sample 2 also decrease. So since we are using different cross flow, the velocity and temperature also different for each experiment.
Hi, I'm Noreen, so we're going to talk about discussion for the lab. The initial measurements for both samples show relatively similar physical properties before exposure to the cross-flow conditions. So, a desalination process was allowed to proceed under constant environmental condition for 30 minutes, ensuring fair comparison to the two cross-flow settings. So after 20 minutes of exposure, sample 1, which is 50% of cross-flow, showed a diameter reduction from 17.2 mm to 17.4 mm and a mass reduction from 4.24 gram to 4.10 gram. However, for sample 2, which is 100% cross-flow, exhibited a more significant reduction with diameter decreasing from 17.4 mm to 16.7 mm and a mass reduction from 4.0 gram to 3.89 gram. This clearly demonstrates that higher cross-flow enhances the sublimation rate of naphthalene. The more intense the airflow facilitates the removal of sublimated naphthalene vapor from the surface, maintaining a higher concentration gradient, which accelerates the phase transition from solid to gas. The reduction in diameter indicates a gradual sublimation from the outer surface, consistent with the expected behavior of solid sublimation under forced convection. The mass loss provides a more quantitative measure of sublimation, where sample 2 experienced a higher mass loss compared to sample 1, despite starting from a slightly smaller initial mass. This confirms that aerodynamic conditions strongly influence the sublimation rate. These observations are consistent with the theoretical principle of sublimation. The driving force for sublimation is enhanced by increasing airflow, which reduces the boundary layer resistance around the solid surface, thus facilitating the mass transfer of submitted molecules into the surrounding air.
Okay, so for the conclusion, the experiment showed that higher cross-flow velocity increased the rate of naphthalene sublimation as seen from the greater mass loss and diameter reduction. The physical change before and after exposure were clear and measurable. Both objectives were achieved, which is to study the effect to air flow on sublimation rate and to compare the physical change at different velocities.
Okay, after the lab is ended, we need to fill the OSH form to evaluate the risk. So we can find 3 activities, which is the first one is set up the apparatus, especially the electrical equipment, which is the risk is the potential of electrical shock risk. And to control it, we need to ensure the proper grounding. And the second one is inserting the sample inside the cross-flow exchanger. The risk is potential exposure to vapor from mothball. And to control it, we need to ensure proper ventilation. And the third one is handling the naphthalene sphere, which is the risk is skin contact, and we need to control it, we need to use the glove. And for the waste, we can find the naphthalene sphere, which is the hazard is potential for chemical to exposure, so we need to keep in suitable closed container for disposal. The overall risk for this activity is assessed to be low.
And that's all from us. Thank you for watching.